Eli, I'm still waiting on your form. Okay, TJ, ready? As soon as the class is respectful, you can start.
Hi, my name is TJ Smith. I'm in Mr. Wilczewski's Research and Design class. It's November 25th, 10th, 11th period, and my research project is whether you can diminish the delay in communications between Earth and Mars. This is my second presentation. I reused the same slide, added a few extra slides on with the information I found during the break, so going over the basic information again, the distance between Earth and Mars, two planets, is 54.6 kilometers. All communications are transmitted through satellites, and there's 6 satellites orbiting through space around Mars. And those are the only ones that are active. There were a few more in the past, but they were deactivated. Messages take about 20 minutes to be communicated one way, and that is determined by the distance between the planets and the how the certain planet is rotated on its axis. No humans have ever been to Mars, but we do have the Mars rover, which is the computerized system that takes pictures of Mars' surface. And then, of course, the NASA Deep Space Network is the program that runs all these communications and monitors the satellites. So the satellites, there's 3 of them in California, Spain, and Australia. They're 120 degrees apart around the Earth, so that there's constant connection to these satellites. They're 34 to 70 meters large. It ranges in size. They can reach about 200 billion meters away. As far as ranging goes, that these antennas share communications, and you can lose communication with some of these satellites because, of course, there's different objects flying through space, and they can easily track onto another object. NASA does not have a way to lock onto that certain antenna for a certain amount of time. For my assignment was to figure out what types of radio waves were used, if there were radio waves, basically like the type of waves, what they were used for, and if I could go faster than the speed of light if I needed to.
My apologies.
Yeah. And I found out that these satellites use electromagnetic radio waves, which is exactly what I was fearing, because these go faster than the speed of light, which is 300,000 kilometers per second. And according to the laws of physics, you cannot go faster than the speed of light, which, I mean, from what we're looking at right now, it kind of makes it impossible to make the communications faster. So satellites would not work, and even if I did add more satellites, it would barely add any, it would barely diminish the delay of communications at all, with a couple seconds. And I do have some costs here on the slide. But yeah, there's still no solution. There might not ever be any solution from what I'm seeing. The only possible way would to find a way to go faster than the speed of light, but of course that's, for what I know, not possible. There would barely be any decrease at all because the radio waves only connect through one satellite at a time. And the cost of one satellite is between $50 to $400 million. 50 is about low frequency, 400 million is high frequency, and I mean thousands of satellites would be needed, and you can see the costs right there. That's billions of dollars, hundreds of billions of dollars. It would be impossible to, get all these antennas back out into space, and it wouldn't even be enough for the richest man in the world to fund. So, yeah, basically we're kind of lost. There's my citations.
Very good. I'm very impressed. Basically, your research failed, but you didn't. All right, and that's what happens. Most research does fail. But to discover what you can't do is a very important part of it, and why you can't do it, because it's based on the speed of light. And so what you're saying is that the signal travels at the speed of light, takes 20 minutes, because it's so many millions of miles away. And the time that's spent between the signal goes from the antenna, right?
Yes.
And to a satellite?
Yeah, 2 satellites and then back down to the ones on Mars.
So the satellites are around Earth?
There's
The first ones?
there's 3 on Earth that are 120 degrees apart, and then there's 6 orbiting around Mars.
Okay, so then the signals, it's a straight shot from the Earth satellites to the Mars satellites. There's no satellites or stations in between.
No.
And even if there were, now this $400 billion cost would be to put more satellites in between?
Yes.
Okay. And even if you did that, you reduce your time by maybe?
Seconds to like a minute.
Yeah.
It would be nothing.
So there's a little bit of a delay in the satellite transfer.
Yeah.
Okay. But not worth $400 billion.
No.
Yeah. Awesome. I'm impressed. I'm impressed. It's not about, I was talking about your project to somebody, and they said, you know, the student's not going to get anywhere with that. And I said, no, I disagree. The fact of going through the scientific process and finding out all the stuff you found out about the speed of light and the cost of the satellites and the frequencies that they work at, now you know a lot more about satellites than you do before, and you went through the proper scientific process. So, I mean, your report is an A+ as far as I'm concerned. You did all the correct work.
I'm kind of at a dilemma now because I was going to try and work with the communications team down the other school, but I mean, I don't know if I'm going to be able to do that now.
Yeah, well, I wonder if they came to the same conclusion. So, compose an email to them and share with them your current findings and see what they got. Perhaps they just, maybe they've come to the same conclusion, they've found someplace else to go. Or maybe they haven't come to the same conclusion yet, and you'll enlighten them. Maybe they're not focusing on the speed of the communications. Maybe they're focusing on something else. Maybe the clarity or the quality, or maybe they want to stream the Disney Channel to Mars. I don't know. You know, I certainly would want cable if I was in Mars. So it's got to be pretty boring. But that aside, what do you see? Where do you think you would go next?
I mean, I think I'd have to start all over with a different project, really.
That's not unusual. That happens a lot in teams like this. You get to the point. I have to think about that. Think about where you want to go next. Is there any way that you're wrong?
I mean, there's no real way to go faster than the speed of light from
Yeah,
what I found, so.
I don't see it. If there was some kind of, like you said, there might be something in the satellites, but the time for the cost is not there.
No, because plus it would be like thousands of satellites for barely even like a minute of,
Yeah.
Delay cut off. And with all those satellites traveling through space, I mean, it would just create clutter and, half of them wouldn't even stay active. So.
Yeah, right. Okay, we got a challenge ahead of you. You did one challenge, now you got another one. To find the new challenge.
I feel like I just wasted 2 months looking that up. So.
Well, you see where I totally disagree with that? Totally. Because most research ends up in a dead end. Because now we know the answer's not down this path. And that's an important piece of information. You see?
Yeah.
And the fact that you've got a tremendous amount of learning here, you've got good research, you know how to research a problem. So you may totally forget all these facts here, but you'll know how to get facts and vet facts and get real facts and not, fake facts. So that itself is more important than the report. You may or not ever see this report again. You may find it, print out the PowerPoint and find it 50 years from now when you're cleaning out your attic. And what you're going to remember is, geez, that was my beginning. That's how I started to learn stuff. Because now a lot of times in high school, we give you information, you give it back. It's kind of like the same thing a computer or a monkey could do. I mean, I'm not comparing anybody to monkeys. But the idea is it's very rudimentary. Whereas in college, hopefully you get into a program where you're gonna have to start thinking for yourself and learning a lot on your own. So you're on your way.
Yeah.
So I'm proud of you. I think you did great. That's awesome. And I'm so impressed. I may ask you to do this presentation again.
Yeah, DJ.
Because it's good science. I'll tell you a story. I had an issue with not too long ago with a college researcher, and his researcher's coming to a dead end, and he wanted to just abandon the research because there were problems with it. There were problems with identifying the bacteria he wanted to identify. There were problems with equipment. The equipment just wasn't good enough. And so he walked away and stopped showing up. What grade do I give him? No, can't give him an A.
Failed that, man.
Can't give him an A. The only grade I give him is a very low grade. Maybe a C, looking at the work he did. But if he sticks to it, and he tries his best, so he shows up at all the scheduled times, and excuse me, if he shows up at all the times, and he puts his work time in, and tries to figure out the problem. All right, so the microscope didn't work. What alternatives? Well, you could do cultures. Right? At this time, I spent a couple hours on the phone talking to supply companies to find out. Say, look, we tried this. Your microscope didn't work. What do you recommend? They said, well, your microscope's not going to work for that unless you stain the bacteria. Okay, what do you need to stain the bacteria? Well, you need stains and you need to do the process. So he could spend time figuring out how to do that process and stain it. What else could you do? You could build a culture. You could culture the bacteria. Then it becomes big and it's on a plate and you can see it. So there are ways around that. So his job is to find those alternate ways around it. Yeah, Oscar?
Question about when things reach the speed of light, they approach an infinite density, correct?
Their mass is supposed to increase, yeah, to
Does that
become
mean light
infinite.
particles don't have any mass? Or is it infinite?
I don't know.
That's the physics teacher.
That's a really good question. No, I've thought about that myself,
That's a physics
and I don't know the answer to that. But yeah, ask a physics teacher and let me know what they say. To me, it doesn't make any sense. You know? It doesn't. I don't like. God, you take a break. I don't like the idea that you're telling me I can't go faster than something. So I like to reject that, even though the data says the opposite. Intuitively, I'm thinking somebody's going to find a way around this someday. And the math is like, what do they say? I looked at it a couple times and I don't really get it yet, but I'm not going to give up.